Hello everyone, I'll talk about binomial expansions today. My name is Tian Chunyang and my student ID is MAT24925. So we have learned about binomial expansions in the class, and this is the equations of binomial expansions. So we can see here, this is x plus a to the power of n. So we can write this like this. So what is the brackets of this? This means c and k. So we can write c and k like a and k over a k k. And what about a? When a m n means we time from m. And m minus 1, m minus 2, dot dot dot. M minus n plus 1. This, we have n numbers here. So this is the meaning of A. And use the meaning of A, we can know the meanings of C. So, this is very hard to know about Y. So I have a good idea to understand about this. This is my easier way. So we can think about x plus a is a box. So to the power of n means we have n boxes. So x plus a, x plus a, x plus a, x plus a. We have n boxes here, and you can obviously find that the power of k and the power of a when the plus k plus n minus k is equal to n. So what means of this? This means we have n boxes, and we must choose k of x's. And the last of boxes. So the other boxes we need to choose a. So this is n minus k. So why we need to time c and k here? So when we choose, so we need to time c and k. C and k means we choose k axis from n boxes. So we need to time c and k because there are many possibilities. So yeah, we need to time c and k. And we need to time the power of k, x to the power of k. But we also choose a, right? Because we choose n minus k, a, the number of n minus k of a. But why we don't time c and n minus k? So why? Because when we choose x, this is equal to we choose a. Why? Because we have n boxes. And if we choose x of these boxes, and the other boxes is a. So we only need to time c and k once here. So this is a to the power of n minus k. And by the way, c and k is equal to c and n minus k. This is equal. You only can use a and k and a k k here to prove it. This is very easy, so I will not prove here. So let's take an exercise here. So we need to find the constant term of 2x minus 1 over 2x to the power of 6. So how can we get constant term? It's very easy if you use my box start. So box, we have 6 box here, and each box is 2x minus 1 over 2x, 2x minus 1 over 2x, dot dot dot, 2x minus 1 over 2x. So we have 6 of this box. So I need to choose 2x or minus 1 over 2x here. So we write like this, plus 1, minus 1, plus minus 1. Plus minus 1. This is like this form. So plus x plus a here. So when can we get constant term here? It's very obviously to just use the constant and no x here. So it's very easy to find. We just need to pick up 3 2x and 3 minus 1 over 2x. This we can get the constant term. No other method to get the constant term. So 2x to the power of 3 and minus 1 over 2x to the power of 3. We choose 2 alpha of k, and the number is 3, right? So I said when you choose, you need to times c and k. So we choose 3 2x in 6 box, so we need to times c 6 3. And when you choose 2x, this is equal to choose minus 1 over 2x, because the other boxes you have no choice but to choose minus 1 over 2x. So this is the final answers. Let's compute it. So c 6 3 6 5 4 and 3 2 1. Right? This is 8x cubed. This is minus 1 8x cubed. 8x cubed, 8x cubed. So this is minus 20. This is the constant term of this equation. So let's go on. This is binomial coefficients and the coefficient, and also the sum of binomial coefficient. So what is binomial coefficients here means? So binomial coefficients means this c and k. Yeah, this is the binomial coefficient. So what about coefficient? Coefficients means binomial coefficients time time coefficients of x and coefficients of y. This all about this is coefficients, and only this is binomial coefficients. So you can say the binomial coefficient is only about n and k. So I can say the sum of binomial coefficients. So we write like x plus y to the power of n. So the sum of binomial coefficients is not about k, it's only about n, because this is c and 1, c and 2, plus c and n. So it's only about n. It's not up to x and y, right? So we can say no matter what x and y is, the sum of binomial coefficients is equal. And also, if the k is equal and the n is equal, no matter what x and y is, the binomial coefficients is also equal. So can we compute the sum of binomial coefficients? Of course, because we just let x and y equal to 1. So 1 plus 1 to the power of n. So this is 2 to the power of n. And this is the sum of binomial coefficients when the power is n. So when n is 2, so the sum of binomial coefficients is 4. So like this, I'm not right here. And let's go on, is the binomial coefficients of odd items and even items. So here is a triangle. The triangle in China named the Yanghui triangle, and like in other country they called Oscar triangle. Is the same thing, and I will talk about name here. And we say the odd items, the sum of odd items is equal to the sum of even items. So let's prove it, but we will find something in this triangle. This is n equal to 0, n equal to 1. The third row is n equal to 2, 3, 4, 5, 6. So what this means, so I'll write an equation that you will know. So we let x plus y to the power of 2. So this can write like x squared plus 2xy plus y squared. So because the coefficients of xy is 1, so the coefficients of these numbers and elements, I think, is equal to the binomial coefficients. So the binomial coefficients of this is 1 to 1. So 1 to 1 and 2. And this is n equal to 2 and 1 to 1. So the Yanghui triangle or Oscar triangle is the list of binomial coefficients in different n. So we can compute some, like this is first, second, third. So first plus third is 2 and the second is 2. This is equal. And let's compute this. First, second, third, fourth, fifth, sixth, seventh. So first, third, fifth, and seventh is 32, and the third, and the second, and the fourth, and the sixth is also 22. So we can say the sum of odd items and is equal to the even items. So I'll prove here. So we have said that C and K is equal to C and minus K. So when n is even, so this is symmetric, like when 6, so this is symmetric. And C and K is equal to C and minus K. So this is 1, 2, 3, 4, 5, 6. So 1, 3, 5, 2, 4, 6 is equal. So yeah, this all this, and this is symmetry. So the even is very easy, and the odd, and this is binomial coefficients. I let x and y equal to 1 to compute the sum of binomial coefficients. So we can also let x, y equal to something to prove this. So x plus y to the power of n, and the n is an odd number. So we let x is 1 and y is minus 1 and to the power of n. So the first elements, I think, is c and 1 and the minus 1 to the power of 1. And 1, any power is 1, so we'll not write here. And c and 2, minus 1 to the power of 2. C and 3, minus 1 to the power of 3, plus dot dot dot. C and n to the minus 1 to the power of n. And we know n is odd, so this must be negative. And the first is also negative, but the second is positive, and the third is negative. So we can say find the odd items is always negative, the even items is always positive, and when the plus is 0 to the power of n is 0. So we can say the odd items, the sum of odd items is equal to the sum of even items. So this is very easy proof. And let's go on. And we need to find the coefficients of x, y squared, z cubed in the expansions of this equation. So we will use my box thought here. So we have one box, x plus 2y minus 3d, x plus 2y minus 3d, z. And we have 6 of this box. So we need the power of x, the power of y, the power of z. When the plus is 6. So we need to choose one x in this 6 box. So this is C61 to times x. And the coefficients, so we need to notice the coefficients of y and z. The z is minus 3. And we have already choose 1x in this 6 box. So I can only choose 2y here in the other 5 box. So we need to time C52 and 2y to the power of 2. And the other box, the 3 box, we can only choose z. So this is 333 to the time minus 3, say to the power of 3. So we can compute this. This is 6 times x times 5, 4, 2, 1. This is 10. And this is 4y. This is 1. And this is minus 27. And this cube. So this is 60 times 4 times minus 27 x, y square, z cube. And this is hard to compute. And this is right answer because my box saws never make mistakes. And this is the coefficients of x, y squared z cube in the expansions of these equations. And this is all I want to say about binomial expansions today. And thank you very much. Goodbye.